Hello everyone, welcome back to my YouTube channel Maths and Matrix, and here I'm back for you to prepare you well for NDA 1 2025 examination. In this video, I have brought for you the top PYQs on derivatives, and I will be covering in parts the top derivative questions part of the examinations from NDA 1 2021 till the latest one NDA 2 2024. Let us begin this session with the very first question, which was the question number 84 in Set A paper of NDA 1 2021. In this question, we have been given a function which is e to the power mod x, and we are asked about which one of the following is correct. When questions on this category, you get look at the options and then think towards it. You can see that in every option they indicate about the derivative of the function at 0, right? And they say the D option doesn't exist. Well, if you know very well about this modulus function, in second you will answer this question and hence the answer option D. But here I am for you to explain why the answer D is correct. So why the answer D? See, you if you want to check the differentiability of the function, you have to cross check the definition. What is the definition of a function to be differentiable at given point? If you want to test the differentiability at x is equals to a, then you have to test the LHD and RHD. Are they equal? If they are equal, then yes, you would say that the function is differentiable at that point a. So what is the LHD definition? The derivative definition for the point x is equals to a, you write it as limit h tends to 0 f of a minus h minus f of a upon h, upon minus h. And for RHD, we write this definition as equals to limit h tends to 0 f of a plus h minus f of a upon plus h. So if you can easily calculate the LHD and RHD with the help of concepts of limits, yes, the first principle of the derivative, and check whether they are equal. If they are equal, then yes, you are thorough with the concept and checking the differentiability of the function. So let us then quickly evaluate the derivative of this given function at the point x is equals to 0 now. Now the a is here 0. So accordingly, the LHD answer will turn out to be limit h tends to 0 e to the power minus h, because it's a 0 minus h, right? You are substituting minus h in the mod of x. So it is e to the power mod of minus h minus e to the power mod 0 divided by minus h. What do you get? You will get this answer to be minus 1, isn't it? Because e to the power mod of minus h, e to the power mod of minus h is e to the power h, and e to the power h minus 1. You remember this result on limit. E to the power x minus 1 upon x as x tends to 0 is 1. So using that result, you are getting this LHD minus 1. And when you calculate RHD, what do you get RHD at 0? You'll get it to be e to the power mod of my s h here, mod of h minus e to the power mod 0 upon positive h. Accordingly here plus 1 will come, and you can see that LHD at 0 is not equal to RHD at 0, which end up telling us that the derivative of this function does not exist at point 0, and hence we say that the derivative f dash is the notation for the derivative of the function, okay, and at 0 we got to know that it doesn't exist, so hence the answer option D. Hopefully you are clear on the concept and keep applying such whenever you see the modulus function part of the given function. Okay. And if you know the shortcut that mod x is not differentiable at x equal to 0, you always can answer these questions in second. Remember well. So coming on to the next question now, 88th question, it was from NDA 1 2021 paper, which asked about the derivative of the function sine of ln x plus cos of ln x. Well, this was one of the easiest questions. So what is the derivative of sine of ln x? It is cos of ln x into derivative of the ln x, which is 1 by x, plus cos of ln x derivative is minus sine of ln x, right? Minus sine of ln x, again ln x derivative into 1 by x. Now why I wrote like this? For this you must remember cos of f of x rule, the derivative of the cos of f of x rule is like minus sine of f of x into d by dx of f of x. So I have applied this rule to sine of f of x and cos of f of x, and there go, you got the composite derivative. That is the derivative of the sine function and then derivative of the angle, derivative of the cos function and the derivative of angle, right? Accordingly, you got this as your dy by dx. But they have asked you the derivative of this function with respect to x at x equal to e. So quickly you can tell me the answer at x equals to, at x is equals to e. It turns out to be cos of ln e. Ln e is 1 because ln e is a natural logarithm where the base of logarithm will be e. So log of e to the base e is 1. So cos 1 by e, cos 1 by e minus sin 1 by e would be the answer, and that gives rise to the option A. Cos 1 minus sin 1 by e, and hence the answer A. Alright, coming on to the next question, part of NDA 1 2021 exam only. And in this question, you have x as a function of t, y as a function of t, and they ask you the derivative of x with respect to y at t is equals to 0. So you know that the derivative of x with respect to y is equals to derivative of the x with respect to t whole divided by derivative of y with respect to t, because x and y are functions of t, and then they are connected as x as a function of y, or you can say y as a function of x. Now we want the derivative of x with respect to y. So we will write in the numerator derivative of x with respect to t and divided by derivative of y with respect to t. So accordingly, if you look at the function e to the power t cos t, when you differentiate this function with respect to t, you will get dx by dt. And when you differentiate y is equals to e power t sin t function with respect to t, you will get dy by dt, and therefore you will get the answer. Now e power t into cos t derivative, it's a uv rule. That's a rule of product of two functions where you're about to differentiate. So it's a minus e to the power t sin t, right, plus cos t into e to the power t. This is all divided by the uv rule applied for e power t sin t, which becomes e to the power t cos t plus sin t as it is e to the power t. Moreover, you are asked to substitute t equals to 0 to know this derivative value. So at t is equals to 0, answer turns out to be, you can calculate now mentally, e power 0 is 1 there, but sine of 0 is 0. Because of that, first term will become 0. Second term will become 1 because cos 0 is 1, right? In the denominator, the first term becomes 1 and second term becomes 0, and hence the answer 1. So option B for this particular question. All right. And now we have another question from NDA 1. Yes, there were 4 questions on and all on derivatives in set A paper of NDA 1 2021. Here they ask you the derivative of the function e to the power x with respect to x to the power e. So let us say the first function to be the u function and the second function to be v function. Then according to the question, you are asked to differentiate u with respect to v. And as per the concepts of parametric function, you differentiate this as differentiate u with respect to x whole divided by differentiate v with respect to x, right? So what is the derivative of u with respect to x? You will say u e to the power x because u is e to the power x. So derivative of e to the power x with respect to x is e to the power x divided by derivative of x to the power e. It's e is a number, irrational number, right? It's a real number. E x to the power e, derivative will be e times x to the power e minus 1. So accordingly, you will get, after simplification, x to the power e minus 1, you can write it as x to the power e upon x to the power 1, and by 1 that x will get multiplied over to the numerator, and that is x e to the power x upon e times x to the power e, and that you can see it is given in the option A. So option A is the right choice. Coming on to the next question, and here we begin with questions from NDA 2 2021 paper now. And this question, if you see, it has been given like a product of 4 brackets, not 4, oh, 5 brackets. So kindly don't sit to multiply them and then evaluate the derivative. You have wonderful application of logarithms into the derivation, that is the logarithmic differentiation technique. So you can apply always log to both sides of such functions to get the derivative done in seconds. So when I apply log on both sides, when I apply log on both sides, I can see that it's a log y is equals to log of a into b into c into d into e. So log of AB formula, it's a log A plus log B. Extending that formula to product of 5 terms, it's going to be log of 1 plus x plus log of 1 plus x square plus log of 1 plus x to the power 4 plus log of 1 plus x to the power 8 plus log of 1 plus x to the power 16. And you know very well now, when you differentiate this function with respect to x, derivative of log x rule will come into picture. Derivative of log x is 1 by x. So that rule going to be applied to every function in the composite manner there, and there you get the derivative. So beginning with log y derivative, it's 1 by y, but y is a function of x, so into dy by dx equals to log of 1 plus x will be 1 upon 1 plus x. Log of 1 plus x square will be 1 upon 1 plus x square into again derivative of 1 plus x square. So 2x in the numerator. Following this rule, you will get the 4x cubed by 1 plus x to the power 4. Then you have 8x to the power 7 by 1 plus x to the power 8. And the last term 16x to the power 15 by 1 plus x to the power 16. Right now, for such a huge derivative based concept, there you have given just a value to evaluate at 0. Now just to imagine the answer mentally there, because you are putting x equal to 0 in everywhere, there is x, so there is x in every step, I mean every term after the first term in the numerator. So ultimately each term becoming 0 after the first term. So you are just remain with 1 by y dy by dx is equals to 1 by 1 plus 0, which is 1. And moreover, the value of y at 0, you calculate value of y at 0. Y at 0 will be like 1 plus 0 into 1 plus 0 into 1 plus 0. 1, 1, 1, 1, 1. 5 times 1, 1 only. So dy by dx at x equal to 0 turns out to be 1 into 1, that is 1, because this y value multiplying it to 1 upon 1 plus x. Hopefully you got the calculation, and hence the answer option B only for this question. Coming on to the next question now, question from NDA 2 2021 only. And here you have, it's like a u into v into w, product of three cosine functions with different inputs x, 4x and 8x. And here you are asked the derivative of 1 by y dy by dx. So they have gave you the hint that 1 by y dy by dx is a part of the log y derivative. So why don't you quickly then apply the log instead of applying the product rule there? So if you apply the log on both sides, this side it will be log of cos x plus log of cos of 4x plus log of cos 8x, and now you apply the differentiation technique there, differentiating the functions throughout the equation. So log y derivative will be 1 by y dy by dx equals to log of cos x derivative will be 1 by cos into derivative of cos x, which is minus sin x by cos x, right? Similarly, when you follow this, it's minus 4 this sin 4x by cos 4x, because first of all it will be like log of cos 4x, which is 1 by cos 4x, again derivative of cos, which is minus sin, but 4x is again an angle, so it's into derivative 4. Like that, the last one you'll get minus 8 sin 8x divided by cos 8x. Now you are quickly need to substitute x equal to pi by 4. Pay attention that you need not substitute at this point, because they are directly asked you value of that expression. So accordingly then you can see that sine by cos is tan. So tan pi by 4, it's 1. So minus 1 this side. And this is sine pi by 4 by cos pi by 4. What is that value? It's tan sine 4x by cos 4x, which is tan 4x, and at x equal to 4 it's become tan pi. Tan pi going to be 0, so this is 0. What about this? Minus 8 times tan 8x. Tan 8x going to be tan 2 pi, which is again a 0, and then the overall answer turns out to be minus 1, and there the choice option A for this question. All right, hopefully this question is clear to you. Coming on to the last question for this session from NDA 2 2021 paper. Yes, in this paper there were 3 questions on derivatives, and in NDA 1 2021 paper there were 4. Okay, so quickly look at this function. There is a composite function f composite f at x equals to x to the power 4. Can you think when the composition of f with itself will be x power 4? Obviously, when f of x is x square, when f of x is x square, f of f at x will be f of x, which is f of x square, which is x to the power 4. Agree? That's why we quickly imagine that the function f of x is x square. So with that, we are here to tell you that what is f dash 1? What is f dash 1? It's a derivative of the function at x equal to 1. So what is the derivative? F dash x equal to 2x. And at 1 it becomes 2. And hence the answer option C for this. Hopefully, solutions explained in this video are clear to you. Revisit the solution again if you face any problem by solving yourself and understand the concept, and keep applying to multiple problems so that you are enough confident on derivative concept. Thanks for watching this video. Do like and subscribe to my YouTube channel if you have not subscribed it, and don't forget to share this video with your friends who are in need. Thank you for watching.